So if you've got 1.8 repeating, it's probably a good thing to note at this point that the only thing that you really need to convert to a fraction is what comes after the decimal. So you can put that 1 that comes before the decimal straight into your answer, knowing that your mixed number is going to have a fraction which is just going to be 0.8 repeating. Now that we've got that out of the way, let's go through how to convert. First, you need to take that 0.8 and give it a name. Leave a little bit of space at the top so that you can actually manipulate it a little bit. Now, the big question here is how many digits are repeating. In this case, you have one digit that is repeating. Okay, when you have one digit repeating, you're going to need to multiply this times 10. So with one digit repeating, you multiply times 10 to the power of the number of digits repeating, in fact. So in this case, you'd be multiplying by 10. If there was two digits repeating, you'd be multiplying by 100 and so on. Okay, so 10x just moves the decimal one space over to the right, and that gives you the 8 to the left of the decimal. And of course, you've got an infinite number of 8s after that 8 to borrow from. So let's just borrow that 8 and say that that's the 8 that's repeating. Now this is especially useful because applying our algebraic technique, we can actually subtract this equation, one equation from the other, right? We can subtract our original equation from this multiplied equation, and the 8's cancel out, so no more repetition. Awesome. Okay, so 8 minus 0 is 8, and 10x minus x is 9x. Remember, that's a count of the number of x's you have. So we do have one problem here, though. We're looking for x. We're not looking for 9x. We're looking for x, and say x here is equal to 1, but it's not really, but x is what we're looking for. So we need to divide by 9, which is the coefficient of x, which is going to get rid of that coefficient of x and give us x equals 8/9. Okay, so our answer would of course be 1 8/9. Now, it is a good point to note that 8 is the number after the decimal that we began with. So in fact, while we have 0.8 repeating is equal to 8/9, or 1.8 repeating is equal to 1 8/9, 1.8 repeating is 1 8/9, note that if you had a 1.4 repeating, say, is equal to 1 4/9, that's especially useful to know because it means that when everything after the decimal is repeating, we can actually skip the algebraic step and go straight to solving the problem. Interestingly, if there are more digits repeating, it also works. 1.74 repeating is, of course, 74/99. Just make sure you're using the count of the number of nines to be the same as the number of digits repeating. Bear in mind that this is only possible when everything after the decimal is repeating. If there is any digits after the decimal not repeating, you must use the algebraic process.